Hello everyone. Today we're going to discuss about the second chapter in standard 11, which is called as trigonometric functions. There are two chapters on trigonometry. One is trigonometry 1 and other is trigonometry 2. We're going to discuss about the first of the two chapters, which is called as trigonometry 1. Now this particular chapter in 11 science has two exercises, exercise 2.1 and exercise 2.2. Today, we're going to focus on 2.1. And mind you, in this particular chapter, there's not much of the things which are dropped due to lockdown, only certain sections of graphs which have been dropped, which I'll discuss. So let's move on to the first part. The first part, you have to understand the trigonometric functions with the help of a circle. Now, as you can see, a circle here. Suppose I draw a circle. Now, this is a circle. In this circle, I'll draw a y-axis and an x-axis. Now this is suppose the y-axis and this is the x-axis. And I can name them as x dash and y dash. There is also an angle. There's also a point P here, which is making an angle theta. So there is an angle theta, which is making, this is theta. Now this point P is called as x comma y, whereas x is the x coordinate and y, which is this, whereas y is the y coordinate, which is this. Now, if you drop a perpendicular from P on the x-axis, you will get something like this. Now, this will be called as, this can be termed as PM, and this is O. Now, what I'm trying to tell you in the basics of trigonometry is that we have to understand that if we take cos theta, and sin theta, let me write here cos theta. Now cos theta will be equal to adjacent side, which is OM, upon hypotenuse, which is OP. Now if your radius is R, which means your OP is R, which is given here, then we can write this particular equation further as cos theta is equal to R upon OP, which is OM, which is your x upon R. OM is x, that is OM is your x coordinate, and this is your R. Now x upon R. Therefore, x is equal to R cos theta. Similarly, I can say that sin theta will be opposite upon hypotenuse, which is say PM upon OP, which is sin theta is equal to, now PM will be your y coordinate, y upon R, and hence I can write y is equal to R sin theta, which means always the x coordinate is R cos theta and y coordinate is R sin theta. These are the two things we should remember. And in case the circle is having a unit radius, that is R is equal to 1, in this case, this x will become, R is equal to 1, x will become cos theta and y will be equal to sin theta. Now your entire trigonometry is based on these two things. So in short, even if you remember x is equal to cos theta and y is equal to sin theta, it's perfectly fine for you. Now let's move on to another concept. Now I have already told you that we have a y-axis and an x-axis. Suppose this is a y-axis and this is an x-axis, y dash and x dash. What we are going to do now is the second part, signs of trigonometric functions in the different quadrants. I had already told you in the previous part that, or in the previous 2.1.1, I already told you x is equal to r cos theta. That is, your x coordinate is nothing but cos theta. Whereas if r is 1, similarly y is equal to r cos theta, r sin theta. So your x coordinate, and if r is 1, your x is same as cos theta, y is same as sin theta. We will come on to that. But right now the second part says you have to understand what are the signs of trigonometric functions in different quadrants. Now let us understand what are the general signs in quadrants. We know that these are the four quadrants. This is called as the first quadrant. Sorry, this is the first quadrant. This is the second quadrant. This is the third quadrant. And this is the fourth quadrant. We know that both x and y are positive in the first quadrant. So if both x and y are positive in first quadrant, which means here the cos theta as well as sin theta both will be positive because x and y are positive. Remember this. So quadrants, first quadrant both are positive. Therefore, a value of cos theta and sin theta will also be positive because x and y are positive. In the second quadrant, which is on the left hand side, your x is negative and your y is positive. Therefore, your cos theta was linked to x. So your cos theta will be positive, or cos theta will be negative, and sin theta will be positive. Similarly, in the third quadrant, if I see both are negative, therefore both cos theta and sin theta will be negative. Here in the fourth quadrant, x is positive and y is negative. Therefore, we will have cos theta which is positive and we will have sin theta which is negative. So whatever is the value, if I tell you sin 30 in first quadrant, if I tell you sin 30 in first quadrant, then that is positive. That is half. Whereas if I tell it is in the fourth quadrant, then the value is going to be negative. Just for now, you should remember that the values of sin and cos are dependent upon the quadrant. And x value depends upon the cos value depends upon x quadrant, whereas sin value depends upon the y quadrant. This is the part which you should clearly remember, that cos depends upon x quadrant and sin depends upon y coordinate. Therefore, in the first quadrant, both are positive, so both sin and cos are positive. In second, x is negative and y is positive, therefore cos is negative and sin is positive. In third, both are negative, so both sin and cos are negative. Here, x is positive and y is negative, therefore cos is positive and y sin is negative. Remember this much part. Apart from this, what we're going to do now is the third part or the third concept, which is called as the third concept is trigonometric functions of negative angles. Now these are the simple three formulas which you should remember. I'll tell you all the three formulas which you should remember. So trigonometric functions of negative angle. Now sine of minus theta is called as minus sine theta. Example, suppose I take sine of minus 30 degree. Now this will be equal to minus sine 30, which is equal to minus half. So that is how you explain sine of minus theta can be written as minus sine theta. Similarly, there is another example. Suppose we take cos. Now in terms of cos, what will be cos of minus theta? Cos of minus theta is given as cos of minus theta can be said as cos theta only. You have to remember these three things: sine, cos. Sine of minus theta is minus sine theta, cos of minus is cos theta. Which means if I have to find out cos of 60 minus 60, which is equal to same as cos of 60, which is half. And last is tan of minus theta. Tan of minus theta is same as minus tan theta, which is equal to, say, tan of 45 degree minus 45 degree is same as minus tan of 45 degree, which is equal to minus 1. So remember this, sine of cos theta minus theta is equal to minus sine theta, cos of minus is cos theta, and tan of minus is tan theta. These are the three things you should remember. Now let's quickly move on to the different questions in the exercise. Now there are questions, exercise number 1. Today we want to do only 2.1. And in 2.1, we'll select few questions which are of different types. The first question is find the trigonometric functions of following. Find the trigonometric functions of all this. So let's take simple. Let's take 60 first. Now I told you that suppose we have a circle. In a circle, you will have to draw these quadrants. And after the drawing, you will have to plot a point P such that this angle is, you will have to plot this point P so that this angle is 60 degree. Now suppose this is P and this angle is 60 degree. This particular angle is 60 degree and this is your P. So P is your x comma y. Now I told you we use unit circles. So whenever we find out trigonometry function, we assume that you have to find out this value, assuming this OP is 1. Now you know that this angle is 60 degree, and therefore you will use this angle, that is this PM will be 90 degree. If this is 90 degree, just a minute, right, again, this angle is 60 degree, this is PM, and this angle is equal to 30 degree. We have studied in 10th standard that the side which is opposite to 30 degrees is half of the hypotenuse. Therefore, if this is 1, this is going to be 1 by 2. Similarly, the side which is opposite to 60 is root 3 times, is root 3 by 2 of hypotenuse. So we have got these values. Now, using this 30, 60, you have got this. Now, P is going to be x comma y. Value of x is OM, which is half. Value of y is root 3 by 2, which is this. Now, once you plot this, once you make a circle and you draw a diagram, then it's much easier. I told you this x quadrant is nothing but your cos theta, whereas this is your sin theta, which means your cos 60 will be half and your sin 60 will be root 3 by 2. That's how we take this. Let's try and take another example. We will take now something which is similar to, say, let's take 150. Now, if I take 150, 150 would come, this will look like this. Then your 150 will be something like this. Now, this is your point P. I will write P. This is your O. This angle is 150. And I need to find out PM, and OP is obviously 1, and OM. Now, since this angle is 150 and there are supplementary angles, this is in linear pair. Therefore, this internal angle POM will be 30 degree. If this angle is 30 degree, then obviously this is right angle. So this angle will be 60 degree. And angle, the sides which is opposite to 30 is half of hypotenuse. So this will be half. And opposite to 60, this OM will be root 3 by 2. Therefore, I can say that my x comma y will be root 3 by 2 comma half, because I have taken this as x quadrant, this as y quadrant, y coordinate. So P is, now for 150 degree, if I have to find out cos 150 and sine 150, we have to use these coordinates. But there is something important. You have to put the sign of the second quadrant. I told you in the second quadrant, your x is minus and your y is plus. Now it is correct. It will be minus root 3 by 2 comma 1 by 2. Now let's try and tell you. I told you your x represents the cos. Therefore, this will be minus root 3 by 2, which will be cos 120. And sine 150, sorry, sine 150 will be 1 by 2. So this is the logic which we use for finding all the trigonometric functions. Now let's try and understand one more thing here. What happens of a negative angle? So I already told you, you will use the same concept for negative angles, which I told you. For example, if you have to find sine of minus 90, you will write minus sine 90. Find about 90, you know sine 90 is equal to 1. So this will become minus 1. So remember, sine minus theta is minus sine theta, cos minus theta is equal to all those formulas used. And once you get sine and cos, you can find out reciprocal, and you can find out sine's reciprocal is cosec, cos reciprocal is sec, using the basic formulas, which we know that sine theta is equal to 1 upon cosec theta. Similarly, we know that cos theta is equal to 1 upon sec theta. We also know that tan theta is equal to 1 upon cot theta. So using these, all the 6 trigonometric functions can be easily find out. And also we know that tan theta is equal to sine theta upon cos theta. So what we need is, we just need these two values, sine and cos. Once we get that, we can find out tan. Reciprocal of tan is cot and reciprocal of sine. This is all what we studied. Let's try and move to the next question. Next question talks about state the signs of these terms. Now there's another thing here. When we make circles, I told you very clearly that we can find angle, we can sine, cos or trigonometric function of any angle. We can do that. But what if it is more than 360 degree? So what we will do is, once a circle is complete, which means suppose we have moved from here to here to here, this is 2 pi or 360 degree. After that, again the circle will start rotating, which means we have studied coterminal angles. So coterminal angles will also be same. So which means if this is 90, if this is 90, it will be same as 360 plus 90, which means 450. So 90 and 450 are coterminous. So the value of sine and cos of 450 will be same as the value of 90. So remember, coterminous angles have same trigonometric functions. That is one of the logics. Let us take an example of tan 380. Now I told you tan 380, what you will have to do is, will be same as tan 380 will be same as, you reduce 360 from it, it will be same as tan 20. Now suppose this is 20 degree. Now tan 20 is in which quadrant? It will be in the first quadrant. And in the first quadrant, both sine and cos are positive. Since sine and cos are positive, therefore tan will also be positive, because sine theta is positive and cos theta is positive. So therefore tan will also be positive. That's how we do. You can take up many examples at your home. Let's try and move on and do few more questions. Now let me do the third question, fifth question, one example. Let's take up this question number. Let's take up question number cosec 45, or I can take first question sine 30. plus sine 45 plus cos 45 plus tan 180. Now sine 30 you all already know from a table will be half. Cos 45 you know 1 upon root 2. We don't know tan 180. For us to find out tan 180, we need to first find out what is the value. I already told you that this is 1 comma 0, this is 0 comma 1, this is minus 1 comma 0, and this is 0 1 comma, this is 1 comma 0 minus 1 comma 0, this is 0 comma minus 1. Now this, all these values which represent, here it is at 0 0 0 0 degree, so this value will be of cos 0 will be 1 and sine 0 will be 0 because x quadrant represent cos and y represents sine. So at each of these points here at 90, this will reflect cos 90 is 0, sine 90 is 1. So if we find out similar way, we can easily find out that 180 is at this point. So cos of 180 will be this value, which is minus 1. And sine of 180 will be 0. Therefore, tan is sine upon cos. So tan of 180 will be 0 upon minus 1, which is 0. This value is again 0. If we try to find out these values, you will get 1 upon 2 plus 1 upon root 2 plus 0, which is nothing but 1 plus root 2 upon 2. You can take a factorize it. This is the way we can solve question number 5. Try to practice the remaining two questions. Any doubt you can ask me. Let's try and do further more type of questions. Remove this. Now in this type, we will have to use our identities. Now there are identities. Now we know that sine square theta plus cos square theta is equal to 1. We also know that 1 plus tan square theta is equal to sec square theta. We also know that 1 plus cot square theta is equal to cosec square theta. Now these are the three identities which we had considered. I'll just once again show you all the identities because you want to use these identities in this type of a question. So once you recap the identities which you have studied in previous chapter, that will be including sine square theta plus cos square theta is equal to 1. It will also include 1 plus tan square theta is equal to sec square theta. It will also include 1 plus cot square theta is equal to cosec. These are the three identities we should remember. Now, so there are two ways in which the question like these can be done. Either we use identities or uh, we use the circle. So let's try to first use the identities and solve this. In this, see, one of the things is given. Say cos theta is given. Cos theta, you have to use this formula and try to find sine theta, and then you can use you can find out cosec with the reciprocal, find cot. So you can find all the values if one value is given. I will show you how. Let me just first remove this and try to take up the first question. Now here it is given that cos of theta is equal to 12 by 13, and I need to find out two values. One is sine square theta minus cos square theta upon 2 sine theta, for which I need sine theta. Let me use my function that sine square theta, trigonometry identity, plus cos square theta is equal to 1. Therefore, I can say that my sine square theta will be equal to 1 minus cos square theta. which is equal to sine square theta is equal to sine square theta is equal to 1 minus, now cos square will be 12 upon 13 the whole square, which is equal to 1 minus 12 square is 144 upon 169. If we take an LCM, it will become 169 minus 144 upon 169, which is equal to 25 upon 169. That is your sine square theta. Therefore, your sine theta will be equal to square root of that, which is 5 upon 13. So you have got your sine theta, you have got your cos theta. Sine theta is 12 by 3, cos theta is 5 by 3. That is what we have done using the identities. Now let us try it and go to this question. Now there is one easy question first. Let's take that. They have asked to find two things, either this or this. Now let's try and find out first tan theta using this. Now tan theta will be sine theta upon cos theta. So I can write it as sine theta upon cos theta, which is equal to sine theta is 5 by 13 divide by 12 by 13. You will get 13 cancel, you get 5 by 12. So that is your tan theta. So therefore your tan square theta will be equal to square of this, which will be equal to 25 upon 144. And the question was asking 1 upon, so we need the reciprocal of this. So 1 upon tan square theta is equal to 145 upon. So that's how you have to find sine using sine, you have to find cos using identities. Cos is given, you find sine. Using that, you find tan, and then you put it. This is how this question needs to be done. I hope this is clear. Similarly, you can do one thing. This part you can practice. You can put values of sine theta and cos theta in this equation and try to find sine square theta minus cos square theta upon 2 sine theta cos. You will get the answer. Let's try and do this last question, question number 9. In this question, there are two ways of doing it. One is I can do the previous way, or other is this method. Now let's try to see what is this method. Now cos theta is equal to minus 3/5 upon 5. We can write it as minus 3k upon 5k. And in the third quadrant, we can say suppose this is theta and this is O, this is P and this is M. I can say my cos theta is adjacent upon hypotenuse, which means OM upon OP. Therefore, I can say that my OM is minus 3k and OP is 5k. So my OM, this is 5k, this is minus 3k or 3k. Now, if I take a right angle triangle OMP and try to use Pythagoras, I'll get OP square is equal to OM square plus PM square, which is equal to OP square is 5k square is equal to OM square is equal to minus 3k the whole square plus OM plus PM square. This is equal to 25k square is equal to 9k square plus PM square. If you solve this, you will get PM square is equal to 16k square. Therefore, PM is equal to 4k. So you will get the other side. So you have got PM as 4k. Once you have got PM as 4k, it's pretty simple, but you can't write PM as 4k. You have to remember that you can write it as minus 4k because it is in the third quadrant. So we have got PM as minus 4k. Once we have all the three sides of the triangle, we can PM, OM and OP. So PM is minus 4k, OM is equal to minus 3k and OP is equal to 5k. All the three sides are there. You can find out any angles. So for example, you can find now sine theta. Sine theta is opposite upon adjacent. So it will be opposite upon hypotenuse, PM upon OP, which is equal to minus 4k upon 5k, which is equal to minus 4 upon 5. Similarly, you can find out other like tan, cot, and all those things. That is one of the way of doing it. Let me try to do the same question using the function identities how I did. This is the last part. Now I will take cos theta as minus 3 by 5. I will take cos theta is equal to minus 3 by 5. Again, if I have to use sine square theta plus cos square theta is equal to 1. Therefore, sine square theta will be equal to 1 minus cos square theta. Therefore, sine square theta can be written as 1 minus, this is minus 3 by 5 square, which is equal to 1 minus 9 by 25, which is equal to 16 by 25. So sine theta will be equal to root of this, which is 4 by 5. But you have to remember the signs. Now in the third quadrant, both are negative. You have to put a negative sign, that is minus 4 by 5. And this is the way you can try and practice the other questions. So I will be, you can do the questions which we have given in the form of Google Forms after this, and just try and solve those 10 questions. I will take up the next part, that is exercise number 2.2 in the second part of this video. Thank you so much. Do subscribe.